All right, good evening, guys. I hope everyone can hear me. Am I audible? Am I audible, guys?
Yes.
Okay, okay, cool. All right, then we'll start. I hope everyone can see the whiteboard. We'll be using this today. I'll share my screen when I will be showing code, but this is what I'll be using for the major part of the lecture. Okay, cool. Let's start then. So first of all, I'd just like to quickly apologize for the delays. I was out of station and was a little sick, so we had to delay this lecture. But okay, let's get started. So, to start with, I'm gonna talk about GCD and LCM. Very basic topics. Hopefully, most people already know what this is. GCD is also known as HCF in some Indian schools, as far as I know. So, they are both the same things. The only thing that I'm gonna be covering here, there's two things technically, but one is again something that you probably already know from school, which is this identity. Wait. Yes. GCD of A comma B into LCM of A comma B is equals to A into B. All right. Okay. This identity is also taught in schools. It's pretty simple. Hope everyone knows this already. I mean, again, this is just reminder. Can you not see? I think you might need to click on follow my view. Is this visible to everyone? The GCD A comma B into LCM A comma B is equal to A into B. Okay, cool. So I would just like to quickly point out this only holds true for two numbers. If you have three numbers, this won't hold true. So just remember that. So now let's get into the actual important stuff. So the first identity, this is used in what's it called? Euler's algorithm, which is it's also used in calculating GCD in general. So let me just, it's this GCD of A comma B is equals to GCD of A comma B minus A. So this looks quite simple. Yeah, Euclid's algorithm, my bad. Euclid's algorithm looks quite simple, but it is very powerful. Yeah. Let me just specify that. Okay. This allows us to calculate GCD for really, really huge numbers, because what you can effectively do is, instead of subtracting A from B, you can use a mod here. So most of you probably don't know what a mod is, so I'll That's the next thing we'll be covering, but basically it's just the remainder when b is divided by a. So you have the quotient and the remainder. This is the remainder. So if I say have 7 mod 5, that's gonna be 2. Now I'm also gonna say this is stuff that we wanted to cover because this comes under prerequisites, but it's not that important for ZCO. I've personally seen very few questions which actually use GCD, so even if you don't get this very much, you can skip it. So now let's come to the actual, what I would call the important topic here. Sorry. That is modular arithmetic. So let's come over here. So the definition of modulo is pretty simple. Yes. Okay. Don't know what happened there. Let me. A mod B is yes. It's quite simple. It's just the remainder when A is divided by B. Right? So first of all, right, why should you care? Because this is basically, you'll find modulo in 5 out of 10 CP problems. And usually what you'll find is at the end of the problem, they'll tell you find the solution to this problem mod some number. And that number is usually going to be 10 to the power 9 plus 7, which is a big prime number. But that's basically like if you see any sort of problem where you have big numbers, that you're going to find that. The reason why we use it is simply to prevent overflow, because for some problems, the results might be in the magnitude of 10 to the 40, 50, 60, which you cannot fit inside an integer or even a long. So that's why we use modulo. Now, what are the properties of mod? Let me just write these down real quick. It's distributive over addition, subtraction, and multiplication. So what does that mean in practice? This means that if I have A plus B, also for using mod, for representing mod, we often use the percentage symbol. So I'm going to use that notation everywhere. C++ also uses this notation. So whenever you see percentage sign, just remember it's mod. This is the same as A mod M plus B mod M. Also a mod M around it. So what this means is, if you have some, do you know what dynamic programming is? DP. Okay, let's go for a simpler example. The recording will be shared on the SPOI server. Say you have some sort of a problem where you have n integers and you have to calculate their sum mod m. Now, if you calculated the sum first and then modded it, that might overflow because you're adding, say, 10 to the 5 numbers. That can easily overflow. But with this, what you can do is you can modulo each number individually, and then after summing, after every sum operation, mod it. Uh, do, do you get that? What I mean to say here. Okay, cool, because that's what you'll usually see in people's codes. You'll see A plus B mod M plus C mod M plus D mod M. You'll see a whole bunch of mods. There's actually a thing called modent that some people use that will clean up code, but I wouldn't recommend relying on that because it's hard to use in ZCO or INOI. Okay, let's go over the next thing, which is subtraction. So it looks pretty much the same as addition because, addition and subtraction, they're pretty similar operations. So modulo also works pretty similarly. The same things that I talked about before, the same is gonna apply here. You're gonna see A minus B mod M minus C mod M, and then maybe some sums in the middle, some subtraction, and stuff like that. The third operation is, of course, multiplication. Okay. Oh, it's interpreting it as markdown. I'll just use X here. Please understand that's the multiplication symbol. So it's also the same thing over multiplication. When multiplying a bunch of numbers together, you can mod them individually first and then multiply. This is also the place where it's the most useful because, multiplication, that will explode very quickly. And again, A into B mod M into C mod M, you're gonna see that pattern everywhere. You can look at any problems code, you're always gonna see something like that. Like there'll just be a bunch of operations chained together with mod M after every single thing. Now, the main thing that you might have noticed is I didn't talk about division, because division is slightly complicated. So technically, modulo division is out of syllabus for the IOI. So it is out of syllabus for the ZCO and the INOI as well. But I will say it is quite an interesting topic to learn. Secondly, it can help Because remember, out of syllabus just means that the intended solution cannot use modulo, but modulo might provide a simpler solution. So it's good to know. Now, for division, there's no clean way to just divide it. So how many people here know matrices? It's in class 12 syllabus in CBSE as far as I know, so I don't think a lot of people will, but how many? Like, could you give me an idea if people here know about matrices? Okay, so you might know in matrices as well that we can't just divide two matrices, we'll instead multiply it by the inverse. Right. I hope people like basically instead of saying that instead of dividing A by B, okay, please give me a second, guys. My screen is lagging a little bit. Just give me a second. Let me shift over to a new page. Whoever's on the last page, please shift over. There's two people on the last page. The last page got really laggy for some reason. So, okay. So instead of this, what we'll do is multiply A by 1 over B, which we'll call the inverse of B. Like, do you kind of get this? The idea of an inverse, multiplication by an inverse. Oh yes, Divjot Sharma, that is correct. We will be calculating the modular inverse. Whoever's using the red cursor, can you please stop? Okay, so how do we calculate modular inverses? So just a quick thing to note. Here I'm only going to talk about modular inverses when the number you're modding it by is prime. So say I told you to calculate A divided by B mod M. We are only going to discuss cases in which this here is prime. Now, a modular inverse can exist even if M is not prime, but that does get a little more complicated, and I've never seen that used in a CP problem. If you're interested, feel free to search it up. It's an interesting topic, but I'm only going to discuss prime mods here. So what is the trick? It's actually quite simple. So the inverse of B is just B to the power M minus 2. Yes, the condition Avigna said is correct. Inverse only exists when B and M are co-prime. But again, don't worry about the general case. We won't be covering it. So, okay, this thing looks a little weird, right? Where did the M come from? Where did this even come from, right? So, yes, when we are not talking about division, M can be anything. The distributive properties I talked about are the same, whether or not M is prime. So this formula actually comes from something called Fermat's little theorem. What that basically states is x to the m is x mod m when m is prime. Right? This is the theorem. And from here what we can derive is x to the, see, I'm just gonna divide both sides by x is equal to 1, and x to the m minus 2 is equal to 1 over x, which is equal to x inverse. So I know that's not really a strict proof, but it's a pretty simple way to understand it. Can you guys follow this? Okay. So one problem that some people are probably gonna think of is, what if m is really big? Like I said in the beginning that a very common value for m is 10 to the 9 plus 7. But of course you can't actually multiply x by itself that many times. That's gonna take way too long. So we actually use a trick for this. It's called fast exponentiation. Yes, binary exponentiation, that is correct. This does kind of fall into CP territory, but I will quickly cover this. So the way this is going to work is pretty simple. This is like, do you guys know what divide and conquer is? Like, not the concept in CP, but what that idea means in general. Yes, that you divide a problem into smaller things, smaller chunks. Merge sort, exactly. That's sort of the idea that I'm talking about here. And what we'll basically do is we'll say that if we have a to the b, right? And now I'm talking about in general. This is not for modulo. This is a trick in general. Although whenever we use fast exponentiation, it is almost always under modulo, because b is usually really huge, and if b is very huge, you cannot store this number normally. So the trick here is that, say b is odd, or let's cover even case first because I think that's simpler. So if b is even, then let's take an example here, right? Let's say b is 10. Then let me ask you, what if I just say I have a to the 10, right? Now that is the same as a into 2 into 5. Now that is the same as a squared to the power of 5. So we halved the power by just performing one operation on the base. It's a pretty cool trick. You can do this whenever the exponent is even. Say if it was 14, you could divide it into a squared to the 7th power. I hope everyone understands this. This is a very simple rule of exponents. Okay, cool. So now I'm gonna ask you guys, what do you think we should do when b is odd? So when b is even, we can see that we can halve the power, but what if b is odd? What if b is 11? Yep. Yep, that's correct. So when b is 11, you can just say it's a into a to the 10, which is the same as a into a squared to the fifth power. I hope everyone can understand this. It's called fast exponentiation. Yep, it's called fast exponentiation. It's a really cool trick. And now, notice this. Once I have halved the power, this is sort of the same question again. I'm asking the same subproblem. What is a squared to the fifth power? Right, I started with an exponent problem. I have decomposed it into the same, but with an exponent that is literally halved. Now, when you're repeatedly halving a number, I hope you guys know that that means that we'll decompose that number to 1 very, very quickly. Does everyone know that? Like even if I had some, really, yes, that is log n. Yeah. Even if I had a very big, say, log, say 10 to the 10, I would be able to decompose that very, very quickly. And due to that, this fast exponentiation trick can find this thing very quickly. X into m plus 2. So I hope everyone understands how we can find this inverse. So if anyone has any questions, please feel free to ask. Because now we are gonna shift to binomial theorem, which is, well, different. If you have any questions, feel free to unmute or put it in the chat box. I'll wait for a minute or two. Does no one have any questions? Alright, then I'll move on. So before moving on, quickly, please look at the chat box. Avigna has posted a CSES problem, which is literally the exact implementation of the fast exponentiation trick we talked about. And okay, I just want to mention this. Even though modular inverse is out of syllabus, fast exponentiation is in syllabus for the IOI. So do keep that in mind. This is the only part, right? The x to the m minus 2 is equal to the inverse of x. That's the only part that's out of syllabus. The other stuff is in syllabus. Okay, well, let's move on. Yes, there will be a blog for this that will be sent out shortly after the lecture is done. Okay, so let's move on to binomial theorem. So how many people already know it? Because I know it's in the class 10 syllabus, so almost everyone should know it already. Okay, cool. A few people do, so let's just cover it quickly. There's quite a few ways of writing it down. It's also written as this. It's the same thing. What it basically represents is how many ways are there of choosing k items out of n items? Like say I had n numbered balls from 1, I had 1, 2, 3 and on till n, and I asked you how many ways are there of picking say 3 balls from this, then the answer will just be n choose 3. Is my voice cracking for everybody? Okay guys, give me a second, I'll just switch over my Wi-Fi. Hopefully that should fix it. Hello, is my voice better now?
Yes.
Okay, cool. Let's go to the start a whiteboard. Okay. Yes. All right. So binomial theorem. Let me just quickly. Okay. So can everyone see the whiteboard? So I'll write the notation down again. Okay, so the formula for this, hopefully again everyone knows this already. It's n factorial divided by k factorial multiplied by n minus k factorial. Okay, cool. So except this, I would actually also like to cover a sort of extension to this, which is I don't know how many people already know this, so I'm gonna ask you the question: what if I again have n balls and I ask you how many ways are there of dividing them into three groups where the sizes are let's take n to be 10 here. Let's take groups of size 3, 3 and 4. Do you guys know how we can calculate that? Okay, so most people know the multiply thing. You can do 10 choose 3 multiplied by 7 choose 3. But there's actually an even simpler way, which I think Yashasvi pointed out, where you can just take the total amount of elements you have, factorial on top, and below you just take the factorial of the group sizes. So say I have 3, 3 and 4, I'll take 3 factorial, 3 factorial, 4 factorial. It's just as simple as that. Just remember these things must add up to give the numerator, right? So 3 plus 3 plus 4 gives 10. So you can't just do with this with like 3 and 3. It should add up to 10. Proof for this. So this is actually, if you look at this formula, you'll realize that both of these are pretty much the same. I'll write it out real quick. So 10 choose 3 is 10 factorial over 7 factorial multiplied by 3 factorial. We have multiplied by 7 factorial over 3 factorial multiplied by 4 factorial. So you can just cancel this out and that's it. Yeah, exactly. It's just a simplification. But three groups will be quantified twice. Well, what do you mean by that? So permuted the groups. I am taking each group to be unique, right? I'm not like I'm assigning each ball a group number from 1 to 3. So I'm not taking these to be the same groups. Okay, I just want to quickly point that out. So I don't have to divide it by 2 factorial. I would have to if those were the same cases, but I'm taking them as unique groups. I don't know if it's a little hard to understand, I think. Do people understand what I said there? Different balls. No, okay. So, people are basically saying same. I'll go back to this question, right? I said that I am assigning it to 3 groups, and the size of the first 2 groups is 3 and 3. So what people are basically saying is, what if you had 1, 2, 3 in one group and 4, 5, 6 in second group and 7, 8, 9 and 10 in third group? And what if you just swap these things? So say the second case would be 4, 5, 6 the first group, 1, 2, 3 as the second group. Yes, they are numbered, they are distinct. Yes, that is what I was saying. So what people are basically saying is these both cases should be counted the same, because you have a group of 1, 2, 3 and you have a group of 4, 5, 6. And what I'm basically saying is that they are different because this is group 1 and over here this is in group 2. Okay, so let's move on to the next topic. So before I start the next topic, I quickly want to mention that this is what I would call the meat of this lecture. It's the most important part because now we are going to be discussing C++. In fact, I would go as far as to say that if you watched Avigna's lecture last week and if you watch this part, you can clear ZCO. Doesn't matter whether you're a male in class 12th, you can clear it. This is legitimately enough knowledge. Not practice, but knowledge. Okay, so let's get into this. So we have quite a few C++ data structures that we're going to discuss. So let's start with the STL. Do you know what the STL is? Yes, standard template library. It's basically the built-in stuff in C++. It's a bunch of built-in tools and functions that you can use. For example, you probably know cout, cin. Maybe some of you know stdarray or sort, lower bound, upper bound. Basically anything that you have used, that's a part of the STL. Yes, whatever's prefixed by std is usually STL. In CP competitions, you cannot use anything except the STL. Sometimes, and keep in mind, this is only sometimes, I've never seen this happen in Zitsio or INY. I have seen it happen in IOI. What they'll do is they'll give you another file with a bunch of functions defined, and they'll tell you that, you can use this stuff inside your code. We are giving you some extra functions, but that is incredibly rare. So you don't need to worry too much about it. 99% of the time you're going to be using the standard template library, the STL. So, okay, before I actually get into the specifics, I want to say that you don't need to memorize anything that I talk about after this. Oh yes, I do want to clarify. You can write your own functions. You can't use some other library. Like, you can't go ahead and use Boost. Okay, so now I want to show you guys a pretty useful resource that you will get during competitions. It's called CPP reference. It's this website. You will get this in contest. You will get this in Zetsio, in INI, in IOI, in EGOI. Any competition you give, you'll get this. This is like the instruction manual in a way. And this has everything. I mean, you can see it on my screen right now. It has basically anything you can think of. You obviously have a lot of date and time, concurrency, that sort of stuff, but you're not gonna use that. The main stuff that we are gonna care about is in this section right here. It's called containers, vector, DQ, array, list, forward list, map, multi-maps, like I've never used it, set, multi-set, unordered map, unordered set. These are the in Zetsio you won't be able to use this URL. In Zetsio, what they'll do is they'll, in the venue, I don't remember this, but whenever you go, they'll provide you with an instruction sheet, or on the website you'll see some instructions about where to access CPP reference, but it will be available. Yes, usually localhost, but I think they gave the zip file of the HTML last year, so that to change. But again, keep in mind they are going to give you the CPP reference. You can count on that. So it is a very good idea to look at this website and try to read it. I know this looks complicated, but, and I'm not gonna talk about reading this today, but after this lecture, go ahead, we're gonna discuss a few of these data structures. Read the CPP reference for those data structures because it will help you. Okay, please do that. Again, it is very, very helpful because once you can read CPP reference, you don't need to remember anything. Literally. What is CPP reference? It's a reference. So it basically means that you don't have to remember anything. Like, there's a ton of functions in the standard template library and you won't have to remember every single one. You won't have to remember the syntax, the speed, the constant. This reference has everything you may need to know. It's basically, yes, if you search a vector, it will give you the properties of a vector. As you can see, it will tell you the complexity. It will tell you the, okay, again, if you don't know what everything means, don't worry too much about it. Just try to understand the basic stuff, like what are member functions. We're going to discuss this today, okay? So if you don't understand this right now, don't worry too much. And yeah, it's not a lot, but it's just about remembering. Okay, so now let's, my bad. Okay, now let's go over the first container today, that is vector. Let me open up a whiteboard again. So how many people here know what arrays are? Okay, cool. So what vector is it's basically a dynamic array. Like arrays, array of integer is, yes, the std array is a wrapper around the C style arrays. Again, if you don't understand, don't worry, just leave it, okay? I'm talking about the concept of an array. It is a list of elements. I just want to repeat what Avigna already said. If you have any sort of questions that are irrelevant to this topic, please wait till the end. I will be free to answer all of them, but not in the middle. Please keep them until the end. Alright, so what is a vector? Vector is just a dynamic array. So you can add elements to the end and you can delete them as well. So arrays in C++, you might know them as int, say whatever the name of your array is, array, and then size here. Right? Hopefully everyone knows this notation. It's the simplest way to create an array. So in this sort of a case, notice the size. It is constant. If I wanted to add more elements, I cannot. And if I want to subtract some, delete some from the end, I cannot. Vector allows me to do that. Now, I do want to emphasize only at the end. In a vector, you cannot just delete elements in the middle. You technically can, but it's going to be very, very slow. It's only efficient at deleting elements at the end. So you do want to keep that in mind. If you have something else, if you need deletions in the middle, there are other data structures for it. How slow? It is as slow as allocating a whole new array, basically, because it's O of n. Okay, so now this is a little low level. So if anyone feels like I went too fast, please stop me immediately, okay? So whenever I define an array in C++, what basically happens is inside my RAM, so inside the system memory, my machine will allocate some amount of bytes in series, basically. Like it will say this was address 1, then this is going to be 2, then this is going to be 3, and so on. Now, just a quick thing, integers aren't a single byte long. Integers are 32-bit in C++, so they are 4 bytes long. Yep, 4 bytes. If you're using long, that is 64 bits. But this is just an example. The point is the same. It's a contiguous block of memory. Now what a vector does is, it also uses the same principle. it will allocate a contiguous block of memory. But it will do one thing that is very special. If, say, I went ahead and added a new element to the end of this array. So if I say added this, instead of just like, okay, if this was a normal C style array, what can it do, right? So it can't just go ahead and write over this memory region. That could be used by some other thing, some other process, some other variable. So you can't just, go on, keep writing in other programs as memory. So what a vector will do is, it will go ahead and allocate a whole new block of memory that is twice as long. Emphasis on twice, because that is very important. So let's say this was 8 bytes long, it will allocate 16 bytes now. And it will copy over these 8 bytes quickly to the first 8 bytes over here. And then it will add this thing right here in the middle. This simple trick, you could say, is why vectors are so awesome. So now some people might be thinking, if it's just going to copy over everything, isn't that going to be really, really slow? Like, what if my vector is, say, 10 to the 5 long? It can't keep copying over 10 to the 5 elements every single time. Whoever has selected or done Control plus A on the whiteboard, can you please not? Yes. So the reason why this is pretty fast is because this is amortized. Say I had an array of size 10 to the 5 and I added something to it for the first time. It will go ahead and create a copy of it that'll be 2 into 10 to the 5 long. So now when I add another thing, it's not going to create a copy because it already has a huge amount of memory. So now I can keep allocating, and it's only once I've added 10 to the 5 things will it go ahead and allocate memory again. Yes, worst case is bad, average case isn't. That's the beauty. In worst case, it's gonna copy the whole array, but in average case, it's just gonna have that memory reserved over. I'm not gonna prove this, but you can just remember that it's constant time. It will is it amortized? O of n log n? No, not really. Not every element will be moved log n times. Only the elements who were at the very start of the vector. Plus, we are covering vectors. Plus, what you'll usually see is that whenever we are creating vectors in C++, we'll just tell the vector how much memory we want to begin with. Like we'll tell it, okay, I want to amortized is sort of like average. Like say I had an operation which took 10 seconds the first time I did it, and then 0 seconds for the next 4 times. Right, 4 times. In this case, I can just assume that it is taking 2 seconds. Yes, the sum is bounded. That's exactly. It's sort of like average. Oh, why does it need to store in contiguous memory? That's because it is extremely fast when it is stored in contiguous memory. This actually boils down to the actual processor. And basically, whenever you have something in memory and you read the next element, that is going to be really, really fast. But if I say was reading this, and the next thing I read was all the way over, say, in just like, 2000 bytes over, well, it's not gonna be that fast because the processor can't optimize that. Again, this comes down to the processor optimizations. Don't worry too much about it. Traversing is going to be fast even if it's not stored in contiguous memory. It's random access which is fast. Say I told you find me the 7th number in the array. Now if it wasn't stored in a contiguous memory, by the way, the thing you're talking about is called a linked list, and it is there in the STL as well. It's called forward list. So say I had one thing over here, one thing over here, one thing over here, one thing over here. Now if I told you to access the third element, how would you do that? Like, you would go to this thing and then you'll go to this node and then you'll go to this node and then you'll be like, okay, yes, this is the element. Whereas if it was contiguous, you can just go to this thing and add 3. Like, you can literally just add something to the memory address and get your result. In fact, this can be used for a really funny thing where, okay, I'm not gonna cover that. It's sort of a meme in C++, but the basic thing you need to remember is it's because you can add. Yes, that's Avigna's exactly right. You're talking about cache share. But again, don't worry too much about that. Whenever you can use a vector, use a vector. Now, in case some people are wondering, when should you use a array over a vector? Because I mean, there are obvious advantages to using a vector, but when should you use an array? The answer is honestly never. I'll be coming over to pushback and emplace back in just a second. The reason why is because the compiler can actually optimize vectors to be as fast as arrays. So there's actually zero reason to use arrays. I know a lot of beginners do use arrays, even I used to use arrays, but if you can, use vectors. It is cleaner and it is just as fast. And it's also safer in some things, but again, you're probably not going to encounter that. Yes, vectors do optimize to arrays if you are compiling with O2 and above, I think, which is the default on judges. So global arrays, again, if you have something that you can, so the thing about global arrays is, unless you're doing something really, really weird, where you can really, really optimize it by storing it in a big global array, then you might benefit from the speed, but anything above that will be just as fast as a vector. How do maps and sets store data? That's through a really weird structure. It's called a tree. Not the tree that you may know, it's a different sort of tree. And that's I think that's in syllabus for the IOI, but I've never seen that being used anywhere. So okay, now let's come over to pushback and emplace back. How do you actually add elements to the end? So pushback and emplace back, again, I feel like you've heard this a few times already, but the compiler is smart. For the most part, there is gonna be no difference whether or not you use pushback or emplace back. because the compiler knows it can optimize. So if you are in the habit of using one, don't worry, like no difference. But if you do want to know what's like the difference in syntax, then that is so the difference in syntax requires you to know classes. But the way that basically works is, same. I had a class. Do people know what classes are? Not in C++, but in general, like object oriented programming. Yeah. Um Again, that's coming in this lecture, but uh I'll quickly go over it. I won't go into the details for now, but basically classes are sort of like your own meta objects which can store different values inside. Like, say I can have a class for car, and that can store its mileage and let's say year in which it was manufactured, and say manufacturer, and so on. Yes, structs and classes are the same. The only difference is that in structs, by default, the member functions are public. In classes, by default, the member functions are private. That is the only difference. Okay, so basically in pushback, what I'll do is I'll take a car and I'll place it here. Classes have any actually no, it's really just here to make your code cleaner. But do remember, cleaner code often leads to less bugs, so it can be helpful. Okay, but in placeback, what will in placeback will do is, you can give it the mileage, you can give it the year, and you can give it the manufacturer, and in placeback will create the car first and then push it. I hope everyone understands that. I'm gonna show you this in code once we discuss classes. So uh, I just glossed over this right now. Anyways, okay, let's move thoda fast now because it's already quite late. So the next stuff is pretty simple. It's a pair. That's literally what it is. It's a pair of two things. That things can be integers, strings, uh, characters, whatever you want. It can be an integer and a string. For frequency arrays, again, you can use global arrays, but vectors are gonna be just as fast and they're gonna be much cleaner. And yes, the main use for a pair is a small tuple. Sort of, but it's a little more optimized. And you can use sort over it by default. There's a few things which makes it tiny bit better, but yeah, functionally you can think of it as the same. Are pairs stored contiguously? Yes. Even if they aren't, actually, if you think about it, it's not that big of a deal because there's just two elements, so it's not gonna use up that many resources. Again, I don't want to get too deep into this because this is gonna get very low level. Yes, the first and second functions. In tuple, you have to use the get function. which looks very ugly, which is why I never use tuples. You have to write this syntax. Okay, so let's come over to the next function, sort. So for sort, it's pretty self-explanatory, so I'll just show this to you in code. Okay, can everyone see Sublime?
Yes.
Okay, cool. So okay, let's start this with a vector. So you guys can also just look at the syntax real quick. It is very similar to an array. If you think about it, what you're just saying is a vector keyword. This is the data type. Like if I were to write this in standard C form, these things are the same. It's a very similar syntax. And now let's just go ahead and let's take 5 elements as input and let's sort. So what's this? Array.begin, array.end. These are basically pointers. Well, they're not technically pointers, they're iterators, but you can also use pointers. Yeah, what they do is begin points to the first element in the vector, end points to the space right after the last element. So if I was instead using an int array, I could just write this as array and array plus 10. Okay, does anyone here know what array means? Like if I have an array and I'm just writing the array instead of writing the square brackets. It is a pointer to the first element. Yes, Devjot Sharma, that's correct. It's a pointer to the first element. And plus 10 makes this a pointer to the element after the last one. Again, don't worry too much about this. Prefer using this thing because it's clean and it's pretty. So now to show you what this does. Oh, amazing. Add 5. Okay, yes. So it just sorts the input. This is like a simple but function that you'll just use a lot of the times. Like you'll just find it in your code. The real power of this function is that it can sort anything. It doesn't have to be an integer. So I talked about the structs, which are cars. So what sort can do is it can even sort it on the base of their years, or maybe you wanted to sort it based on their mileage. It can do that. Yes, strings can be sorted too. Yes, comparator function. This function Uh, you can make it sort based on anything. That's up to you. What sort takes here, so a third argument is you can give it a function here. This function should have the signature this. It should return a boolean value. It should take in a reference A and I forgot a const. Yes. Reference A and B. This can be anything. This doesn't have to be an integer. It can be a string. It can be anything. And what it should do is it should return okay, now this is something that CPP reference is going to help you with if you forget this, right? So if I yes, this is the thing where CPP reference is helpful. So I was talking about sorting this, right? We give it the first thing and we give it the last thing. And this is what we are talking about now. When we give it a compare function. Yes. See, parameters, it explains to us what the comparison function should be. Exactly the thing I told you, right? A boolean, and should take in const and references. Now, the important part here is this. It should return true if the first argument is less than the second. Now, how you define that is up to you. Sometimes, again, that might be based on the year, that might be based on the mileage, that might be based upon the year in which it was introduced. It can be literally anything. I hope that's clear. Is that clear, guys? Can you put some yeses or nos in the chat? What about 2 plus elements? You don't need to care, because the sort function just does that for you. You just need to tell them, if they give you 2 objects, you just have to tell them which one is less. That's it. The rest, the STL is going to handle. This is like one of the reasons why the STL is so powerful, because you don't just need to give it what it needs and it will do all the heavy lifting. All right, let's go quickly over to the next 2 or actually 4 things that we'll be covering, which is sets, maps, unordered sets, and unordered maps. So these are, let's go to the whiteboard again for this. Yes, equal elements should return false. If you don't, then you'll get undefined behavior. What is the var array actually holding? Array itself is holding the pointer to the first element. Okay, so let's cover sets first. So sets are basically like they're sort of like an array, but not really. In sets, again, you just have a list of integers, but in case of sets, you have it automatically sorted. Like say I have 1, 2, 3, 4, and if I add 5, it will automatically add it over here. It will always remain sorted. That is the main property of a set. The places where it's different to an array is that you can't ask it what is the third element, what is the fourth element, what is the fifth element, because it has no knowledge of that. So if I have this and if I ask what's the second element, it cannot tell me. What a set can do is it can binary search. Ordered sets, yes, ordered sets can do this, but they are not a part of the STL. They are a part of PBDS or the GNU compiler extensions. I'm not gonna discuss them today, and they're not required, and they're not that useful anyways. There are some niche use cases, but set is kind of like a mainstream data structure which you'll actually use in a lot of places. So where would you use a set? Well, it just depends, right? It just depends. If you have something where you need to binary search real quick, like say I had this, I have a bunch of elements being added to my array, and I have to ask the question, does the element X exist in the array? So if you have this, if you have these two queries that you have to answer, you can't do this with an array, because with an array you'll just add it to the end, but for querying you'll have to loop over the whole array, right? So you have the array. If you have an add query, you'll add it to the end, but if you have a question, then you'll have to loop over the whole array, O of n. That is very slow. But sets can, for repeated elements, there's something called a multi-set that supports multiple elements. Okay. So for a set, what I can do is I can add these elements, and a set will keep them sorted. And when they are sorted, I can answer the questions using binary search. Do people know what binary search is? Okay, cool. But that's kind of the main use of set. Again, you're not gonna find this being used too much. Vectors are gonna be the main thing. So let's move on to the next thing, which is maps. Maps are sort of like a set of pairs where you can basically say, so I think people probably already know what a map is. I think it's quite popular in other languages as well. So a map literally maps A to B. That's what a map does, literally. Like I can map strings to say integers. I can create a map from integers to characters, and a map will just do that. Yes, it is a dictionary. Yes, exactly. Again, you can think of it as a set of pairs, really. It's not that different. I hope both of these things are clear, because I went a little quick. If anyone has any doubts, please put them in the chat or unmute, because I'm gonna be going over unordered maps next, which are slightly different. Okay, so an important thing here, in a set, all of these queries I talked about, adding, subtracting, or asking, does this exist in the set, are all logarithmic time. An unordered set is slightly different. When unordered, we'll usually look at maps, not sets. So let me discuss that first. Unordered maps are basically the same as normal maps, right? You can map strings to integers, integers to correct. You can map anything to anything. The difference, unordered maps are O of 1. They are constant time, because they use something called hashing. Do people have a sort of idea what hashing is? Okay, cool. So I'm not gonna cover hashing in detail, because honestly you can black box it. Just know that it is O of 1. It is constant time. It's very fast. Although it can actually be broken, but it's a little weird. You need to add some code to the top of your file to make it not broken on code forces, but only on code forces. In a CP contest, in a OI contest, that is just fine, right? You just do an unordered map from, say, string to integers, you use it in your code, it's gonna be fine. No one's gonna break that. Okay. Not recommended. It depends. If you have something where you need constant time, then you should try a map. See, the thing is, the syntax is exactly the same. So you can literally just try. It's you can literally just try. Is it memory safe? Yeah. It's memory safe. The break part is that people can get that's kind of into hashing, so I'm not going to discuss too much, but it'll basically make your queries very, very slow. There is a way, but it's not used in OI. It's only used on code forces. And the important part, the important difference, the normal set comma map, you can binary search. So you can binary search in these, and you can also iterate. With unordered versions, you cannot binary search and you cannot iterate, which is sort of important. Say I have a set of 1, 2, 3, 4, 5, and I told you I need to remove 3 to 5 numbers between 3 and 5. I can do that in a set. I cannot do that in an unordered set. Keep that in mind. Set takes more time. It does take logarithmic time, but it doesn't sort it. It uses a tree structure to maintain the sorting as you add elements. But yeah, the only part you need to worry about is that it is logarithmic. It takes log n time. Okay, moving on quickly to the next topic, which is the auto keyword. This is very simple. It's just sort of like you're letting the compiler guess what data type is supposed to be there. So if I say have a function that is returning an integer and I set auto to be the return value of that, the compiler will guess that it is an integer. Unordered set is it's honestly a very useless thing. Unordered map is what you should worry about. It's just a mapping between two data structures, which is very, very fast. So auto keyword, again, I'm gonna show this in code, but this is pretty simple. It's just a way to make your code prettier. So say I had a function which returns a plus b. Let's do this 2 and let's do 1. So here, now I can obviously put an integer here because result should be an integer because the function is returning an integer. But if sometimes the data type can be very long, or maybe you just don't want to write it down because it's simpler to just use auto. Just let the compiler guess. It's pretty simple and it just works. I hope everyone gets what that means. Yes, iterator, that's the main use for this because the iterator types are usually really, really long. So if I was iterating over something, I would take it in an auto thing. I hope that's clear. Because I'm going to move on to the last topic now. Is that clear, guys? No, you shouldn't replace int with auto because auto is also going to hide the data type from you. Like say if this was a really long piece of code and I had auto res is equal to some weird function, even I wouldn't know what res is. This is useful when your data type is really long. Sorry. Okay, so is this clear? Is the auto clear? Is unordered set clear? Unordered map? If anyone has any questions, please ask them. Auto is int, then can it be changed to no. Auto is not auto is still gonna be a data type, right? It's not like Python where you can just set something to an integer first and then change it to a string and then change it to something else. You're just letting the compiler guess what it is. So you're like, okay, I'm too lazy to type this out. You already know the return value of this function. You already know that the result is going to be an integer. It's going to be a string. It's going to be something XYZ. So just set it to that. Don't make me type it out. That's literally what auto is. What you're saying can be done using different data types. I think it's called a union, if I'm not wrong. Okay, cool. Then I'll move on to the next topic, which is structs. So a struct, as I talked about, it's pretty simple. You have an int, you can have integers here, you can have strings, you can have anything, you can have floats, you can have anything as a member. It is just sort of like a clump of it. It's like just a bunch of integer strings and just a bunch of primitive data types bundled together. Do you get what I mean by that? A difference between class and struct. So, oh, that's a spelling mistake. A class is basically the exact same, but inside a class, these things aren't accessible by other functions, other code by default. So it's only accessible by other things inside the class. That's the only difference. By default, in classes, everything is kept private, kept locked down. In struct, everything is kept public. A struct is a way to make your code cleaner. Say I had something where I was talking about cars, right? Instead of creating 3 different arrays like mileage of car, year of car, and manufacturer of car, I can just create one vector of cars, which is gonna just call this manufacturer, okay, which can make our code very simple, because now I can just say a vector of car of size 2, and that's it. Now I have 2 cars and both have their mileage. Yes, that is the same, Madhvik. So you just have 2 cars with their mileage, year, and manufacturer. Set. It's a way to make code cleaner. Is this slower? No, not really, but it's not faster as well. A compiler will optimize everything. It is just a way to make your code cleaner and easier to write, which, keep in mind, again, can usually lead to less bugs and is therefore very helpful. So, do people get this? Because this is C style structs. I haven't talked about the C++ specific features yet. Do people get this much? Like what a struct is? Okay, cool. So, the next thing I'm going to discuss is member functions, which is, let's say I wanted a function which can return the expiry of my car. This is how it would look like. Just a function, instead of defining it out over here, I defined it inside this class, and I can access the things inside the class automatically. Does that make sense? People who have already used object-oriented languages probably would find this pretty easy, but if there's anyone who doesn't quite get what this is supposed to be, please do say so. Okay, cool. Is it like double vector? What do you mean? What do you mean, Aditya? V1. Uh, I am not quite sure I understand what you mean. Uh, yes, yes. Please feel free to unmute.
Am I audible?
Yeah.
So we are like creating a vector, and in it we are creating another vector of one kind of object. Like for example, if we take the car, we are creating mileage, manufacture, like that.
Oh, uh, no, not really. Like a car is just like a bunch. It doesn't have to be allocated together. It doesn't have to be the same data type. In a vector or in an array, you need everything to be the same data type.
Oh, okay, okay, got it. Thanks.
Yes. Okay, so this is member functions. This is basically the same as if I just said taken a car and say C dot here. This is the exact same thing. Do you guys get what I mean? Okay. All right. So uh, just go over some sample code quickly. So let's say I had a car. Say I don't know. Let's take A with so okay, now the thing is, how do you actually create a car? Like, how do you assign it values? So one of the ways would just to be to assign a car A and then set A dot um, mileage to be something, and then A dot year to be something, and then manufacturer to be something. But a different way you can do this is by using this syntax: mileage, year, and manufacturer. So say this was 20 kilometers per liter, and let's take a 2025, and let's take Maruti. So this works. It's a whole lot cleaner, and this is gonna tie in directly to pushback and in place back. I hope that syntax is clear. Okay. So now question is, what exactly did I do here? Like, how did the compiler know that this 20 was talking about the mileage and this 20 was not talking about the year? And what if I wanted to, say, define this in a different way? Right. Say I had some else value that had to be calculated from these two values. How would I do that? So this is where constructors come in. So the way a constructor works is that you can pass it all the values you want. And inside the constructor, you can actually assign the values. Will be, okay, let's take this to be string, call this C. And let's say we had some other calculated value, which was A plus B. I can do this. inside the class, and now this 20 is going to be passed as A, 2025 is going to be passed as B, and Maruti is going to be passed as C. And now you can use them and assign them in whichever way you want. If you don't want to set the year, you don't have to. But remember, by default, it will be set to some garbage value. Again, I'm gonna talk about pushback and in place back. That's where this curly brace thing will be more applicable. So do people understand what I did here? What this function is? It's just curly brace notation is passing it into a function with the same name as the class. That's it. It's just another function. Okay, so now this is what in place back is. So if I have a vector of car, say A, and if I do in place back, I can directly pass in these arguments. Okay, so I can directly pass in, because what in place back is going to do is it's going to take all of its arguments, it's going to pass it into this car function. This is literally all that in place back does. Just a way to easily call that car function, create a new car, and then add that car to the vector. Pushback, on the other hand, is useful if you are pushing a car. So say, let's name this C. If you're pushing back C, then pushback would be used. You can actually use in place back over here as well. Again, no difference. The compiler is going to optimize. Car won't be named, yeah, because it's in a vector. So now it's just some index in the vector. Okay, so I hope all of that is clear, because that is it for today. If you have any doubts about classes or structs, member functions, the curly brace notation, please feel free to ask them. Otherwise, I'll start taking general doubts. Alright, if no one has any doubts about class and structs, I can take general doubts now. Okay guys, feel free to put general doubts in the chat or unmute if you want. From where can I practice the discussed topics? For the modular stuff, Avigna already sent a problem. For the vector and pairs, there's no website we can exactly practice this. It's just whenever you're coding a problem, just use these. And for the classes and structs, again, it's basically the same thing. You'll get better once you start using it. So just sort of make it a point to use these things instead of C style stuff and C style arrays in your code. Yes, it's like a tool. Just get into a habit of using it. That's really the best way. What topics have been covered till now? Avigna's lecture was an introduction. We'll be uploading its recording soon as well. as well as this lecture, so you can watch them both. And again, I would say that both of these are pretty much enough to qualify for ZCO as far as pure knowledge goes. Where do I practice from to get a better rank in TC? That's a very subjective question. Some people practice code forces, some people prefer to practice Olympiad problems. My personal recommendation would be to practice problems from other Olympiads, specifically the National Olympiad of Singapore and the Croatian Olympiad. And if you're up for something more, try the Japanese Olympiad in informatics. Class 10, please suggest combinatorics. Combinatorics, you don't need to know too much for OI. And honestly, I don't think I can answer this question because I personally don't know combinatorics that well. And again, you don't need to know combinatorics, just remember the binomial theorem, and that's basically it. How much larger is the INOI syllabus? It is the exact same. Both are the same as the IOI syllabus. Which Japanese one? For INOI, I would recommend the Japanese Olympiad in Informatics final round. USACO guide good for practice? Personally, I would say no, because USACO problems are different than Indian OI problems. INOI in particular places a lot of emphasis on solving problems under time pressure and also taking subtasks, which is just not there in USACO. Yes, I have witnessed MLE, although it is quite rare. Unless a problem is, really built to make you optimize memory, you're never gonna experience that really. And there are not a lot of problems which try to actually test you on your memory. Most problems are trying to test your speed only. Where do I practice already learned topics from, like DP and segmentary? If you want to learn, if you want to practice the basic implementation, my personal choice would be CSES. If you want to try some advanced problems, then it's probably best to just search up. There'll probably be some code forces blog or some post on your USACO guide, honestly, which will give you some hard problems on those topics. Is USACO guide good for concept learning? Yeah, sure. If you prefer reading that style of blogs, it's perfectly fine. What is the ideal proportion of practice to really learn CP? Ideal amount of practice, well, that's very subjective. I don't think I can answer that. A CP handbook is a personal favorite of mine. I have a printed copy of it in that cupboard. It's like a CPP reference but for algorithms, honestly. It's really just a reference book. It doesn't go too deep. It just gives you the code, it gives you some basic logic. Really useful. CSCS, again, for practicing basic implementations, if you just want to learn a lot of topics, it is the best resource in my opinion. Mock contests, again, one of my favorites. I would recommend mocking NOI Singapore and uh, Croatian Olympiad. Like where to find the practice problems. Again, just Google them. You'll find some post on Codeforces. Any other question, guys? How to manage the time management. Um, Time management should really just be greedy. Like, say this was one of those things that my mentor used to tell me, that if there are two problems and you score 60 in both, that's better than scoring 100 on one. So it's always best to just try to greedily go for the most points you can. And subtask to aim for, this is sort of like a skill, really. This is something you'll develop with practice, but a good hint is to look at how many points there are for that subtask and what is the subtask number. Say if this is like the first or the second subtask and it's worth say 40-50 points in INOI, then that's probably going to be an easy subtask. But if it was a, say, last subtask worth 20 points, then that's probably going to be hard. Yes, I did have a mentor. I did have him between December of 2023 and April of 2024. After that, self-study. Plus, I'm not really grinding CP that much now, especially with the college admissions coming. After qualifying ZCO, well, no, actually, in 2024, ZCO was held in April. So this was way before ZCO. No, I am not giving the JEE. And CP, I'm not studying it right now because I have other stuff, but of course I'll study it before IOI and IITC and INOI. Any other questions, guys? Feel free to ask. Right, if don't have any questions, then bye, guys. Good night. Strategy for ZCO. For ZCO, The good thing is that it's a 3-hour exam, and the question difficulty is not proportional. What I would suggest doing is starting attacking problem 1 and just looking at getting like 20 to 30 points, right? Because the cutoffs are very low. Don't worry about getting 100, don't worry about getting even 80 or 90 points. Go for easy and simple. Go for stuff that you can very easily get. And once you're sort of done getting those 30-40 points that were like literally free, shift to problem 2 and again get those 30-40 free points. After this is done, right, after you have that 50 to 60 points sort of a base, you can go ahead and switch between those problems freely based upon which problem you feel like is more scoring. Like maybe the problem 1 is based upon prefix sums and I think I know them pretty well, so I'll spend some time on that. But just remember, get that 50 to 60 points ka base. And CF rating of ZCO, I think it's around 1,000, probably. See, the problems are difficult, but the cutoffs are very low. So I'm talking about rating proportional to cutoffs. Acing is probably like 1800 or something. Alright, guys, any other questions? Otherwise, now go to sleep. It's quite late. Have dinner, hopefully, if you didn't already. Good night. Location of CPP reference provided with instructions. It will be in the instructions. Read the instructions. They'll write, okay, you can find CPP reference at this URL, at this directory on the computer. Just open that up. Good night. Bye.